Section 11.5 Solving Quadratic Inequalities. Okay, so first let me give you some examples. So suppose we have, so first, standard form. So a inequality of the form, some polynomial or even rational function greater than or equal to 0, greater than 0, less than or equal to 0, less than 0, will be said to be in standard form. So standard form means that the right-hand side of my inequality is 0. Okay, so let's do on page 491, problem number 2, 4x squared greater than or equal to 7x plus 2. Subtract 7x, 2 from both sides of my inequality to make the right-hand side of my inequality 0. So I have 4x squared minus 7x minus 2 is greater than or equal to 0. So this is in standard form. Now actually, we usually like to write it in standard form where I factored the left-hand side as much as possible. And so in this case, you could actually factor this as follows. 4x squared minus 8x plus 1x minus 7x minus 2. And so this is in standard form, and we've simplified this inequality as much as possible. Let me do problem number 6. 0 greater than negative 13x plus 7 minus 6x squared. Now, I want that the right-hand side is 0, so since I have a minus in front of the x squared, I guess I'll add 6x squared, 13x minus 7 from both sides of my inequality. So I have 6x squared plus 13x minus 7 is greater than 0. I guess you can't quite, let's just see. 14 and 3, 21 and 2. I guess if that was a plus sign instead of a minus 7, I could factor it, but I don't seem to be able to factor it over the rationals. I can factor it, of course, over the complex numbers, but let me do problem number 10. 3x squared plus 7x plus 2 is less than or equal to 0. So we had in exercises 1 through 8, we wanted to write the inequality in standard form. Now, in exercises 9 through 20, we want to find the critical points of the inequality. So let's determine my critical numbers. So first, I want to factor. And so let's write notice that first my inequality is in standard form. The right-hand side of my inequality is 0. And so let's factor this. And so if I write this as follows, 3x squared plus 6x plus x is 7x plus 2. I factor this as much as possible. And so I have written this in factored standard form, in simplified standard form. So now let me determine my critical numbers. In order to determine my critical numbers, I just set each factor equal to 0 in this factored standard form. So subtract 1, subtract 2 from both sides of my inequality. So 3x is equal to negative 1, x is equal to negative 2, divide by 3. And so I have x is equal to negative 1 over 3. So I have two critical numbers. X is negative 2, x is negative 1 over 3. Let me do problem number 20. So again, I want to determine my critical numbers. Luckily, this is already in simplified standard form. So to determine my critical numbers, I just have to set each factor to 0 and solve for x. Add 1, subtract 2, add 3 to both sides of my equation. So x, is equal to 1. X equals negative 2. X equals positive 3. Let me do problem number 22. X minus 3, x plus 5, greater than or equal to 0. In exercises 21 through 29, solve the inequality and graph the solution. So the first thing to do is to put it in standard form. It's in standard form. To write it in factor standard form. It's in factor standard form. And then determine my critical numbers. The reason to put it into standard form is that once we have, the only way that the left-hand side of the inequality can change sign is at these critical numbers, when the left-hand side of your inequality is 0. And so we can then determine when the inequality is true and false by looking at these critical numbers, and those critical numbers will then subdivide our number line into subintervals. And in the subintervals determined by the critical numbers, the inequality will not, the left-hand side of the inequality will not change sign. And so let's determine critical numbers. So from there we could determine the solution to the inequality. So determine the critical numbers. Set each factor to 0. Solve for x. Add 3 to both sides of your inequality of your equation. Subtract 5 from both sides of your inequality of your equation. So x is 3, x is negative 5, And so let's place those on our number line. So -5, +3. Take a number greater than 3, let's say 4. So please notice that in each of these subintervals, the interval for values of x greater than 3, for values of x between -5 and 3, for values of x less than -5, that my inequality, my left-hand side of my inequality will not change sign. And so if I take a number greater than 3, let's say 4, then x minus 3 is positive, x plus 5 is positive. Positive times positive is positive. If I take a number between -5 and 3, let's say 0, then x minus 3 is negative, x plus 5 is positive. Negative times positive is negative. Take a number less than -5, let's say -6. And so x minus 3 is less than 0. X plus 5 is less than 0. Negative times negative is positive. Since we want this left-hand side to be greater than or equal to 0, then the left-hand side must be non-negative. And so I'll fill in where it says plus greater than 0. And we want it to be greater than or equal to 0. So it could also equal 0, therefore I'll fill in both of these critical numbers. And that is the solution to my inequality. It is just the union of the two, it's just the union of the two closed intervals, -infinity to -5, 3 to infinity. And so it's this closed set. Let me do problem number 28. 3p minus 1, p plus 4, less than 0. And so this is already in reduced, factored standard form. Therefore, I can determine my critical numbers. And so 3p minus 1 is 0. P plus 4 is 0. So you just set each factor equals 0. Solve for p. Add 1. Subtract 4. So 3p equals 1. P equals -4. Divide by 3. Divide by 3. So P equals 1/3. And so let's put these on my number line. And so I have here -4, 1/3. So let's take a number greater than 1/3, 1. And so in this case, 3p minus 1 will be positive. P plus 4 is positive. Positive times positive is positive. Take a number between -4 and 3. The easiest one to choose is 0. And so At 0, 3p minus 1 is negative. P plus 4 is positive. Negative times positive is negative. Take a number less than negative 4, let's say negative 5. At negative 5, 3p minus 1 is negative. P plus 4 is negative. Times negative is positive. And so we want this to be less than 0. And so let's fill in everything under the negative sign. And it says here there's no equals, it's just strictly less than 0. Therefore, I will leave these critical numbers as open circles. We will not include the critical numbers. And so my solution is just the open interval negative 4 to positive 1/3. And that is your answer. Notice that these seem to alternate. And in fact, you can tell if the signs will change by just looking at the power of each of the roots. So it turns out that if your root has odd multiplicity, so if the root has odd multiplicity, such as in this case it has a, well, let's say here, it has a power of 1, so a simple root, then the signs will change. When you cross that root. Whereas if the root has an even multiplicity, such as if this was 3p minus 1 quantity squared, so if there was a power up here of 2, then the sign would not change when you cross the root. So the signs do not change when you happen to cross that root. Okay, so let's do problem number 32. X squared minus x minus 2 less than or equal to 0. In exercises 30 through 56, solve the inequality and graph the solution. So let's do that. And so it's in standard form, but I want it to be in factor standard form. Let's factor this. It's a nice monic polynomial. And so I'll drop down the negative times negative is positive. I want two whole numbers whose product is 2 and whose difference is 1, so 2 and 1. You put the larger root first. And so now it's in standard form, factor standard form. So let's determine my critical numbers. Set each factor to 0. Solve for x. Add 2. Subtract 1. So x is 2. X is negative 1. And so I have place your critical numbers on the number line. Take a, let's say 0. That's the easiest one. And so at 0, x minus 2 is negative, x plus 1 is positive. Negative times positive is negative. Since each of these roots are simple roots, then, well, at 2, it's going to change sign. At negative 1, it will change sign. I want this to be less than 0. And so I will fill in where it says plus. And I want it to be less than or equal to 0. So let me fill in each of the critical numbers. And so my answer is the closed interval -1, 2. Let me do problem number 52. 3r squared plus 15r plus 18 less than 0. Let's factor out of 3. R squared plus 5r plus 6 less than 0. Let's factor. It's a monic polynomial. Bring down the plus. Times plus is plus. I want two whole numbers whose product is 6 and whose sum is 5. 3, 2. Set, and now let's determine my critical numbers. Set each factor to 0. R plus 3 equal to 0. R plus 2 equal to 0. Subtract 3. Subtract 2 from both sides of my equation. So R equals -3. R equals -2. Place those on your number line. -3, -2. Let's pick a number greater than -2. Let's say 0. And so 3 is obviously positive. R plus 3 at 0 is positive. R plus 2 at 0 is positive. So positive times positive times positive is positive. Each of these roots have multiplicity 1, an odd power. So they alternate. And so we want this to be less than 0. And so I fill in less than. And it says strictly less than, so I'll leave these as open circles. And so your answer is the open interval -3 to -2. Let me do problem number 56. 4t squared plus 20t plus 25 less than 0. Let's factor this. Well, this is a perfect square trinomial. The square root of 4t squared is 2t. The square root of 25 is 5. 2t times 5 times 2 is 20t. And so, yes, is indeed a perfect square trinomial. And so, let's determine my critical numbers. And so, let's set 2t plus 5 equal to 0. Subtract 5. So 2t equals -5. Divide by 2. And so t is equal to -5 over 2. Let's put that on my number line. Take a number greater than -5 over 2. Let's say 0. And so 2t plus 5 at 0 is positive. Squared is again positive. And so that's positive. The degree of this root, the multiplicity of this root is 2. So it's a double root. Since the multiplicity is 2, that means that it's an even power, an even root. So therefore, since the multiplicity is even, it will not change sign. So the other side is positive. We want this to be less than 0. So, well, there's no minuses to fill in. And, well, we want this, there's no equal sign, so I don't fill in the critical numbers. Therefore, I don't fill in anything. So my answer is the empty set. So there is no solution. So this particular problem has no solution. And so that finishes off section 11.5.